going on. We're going to learn how to take a number that's in scientific notative form and change it to its normal way of looking, which we call standard form. So I have a number that's in scientific notative form in front of you right now. And as I try to do with all of my math, I want to make sure that we're thinking about money. So when I look at a decimal number like 2.15, I really want to think, all right, that's $2.15. Well, is it really $2.15 or is it disguised? Well, I'm going to show you. It's really disguised. And it has to go back to why we use scientific notation in the first place. We use scientific notation because we don't want to write out all the zeros to really, really big numbers. So this is a very small number compared to some of them that you're going to see. But in order to be in scientific notative form, it has to be a number that falls between $1 in size and $9.99. We're not allowed to have a two-digit number or anything bigger than that, and we're not allowed to have anything smaller than a one-digit number. So it can't be like 50 cents. So $2.15 falls between that range. So this is in scientific notative form. Well, what dollar amount is this truly? Well, what we're going to do is we're going to understand that 10 to the third power is actually saying that we have 3 extra place values to give to our $2.15. So if I write down $2.15 and I say I'm going to give it 3 place value, that's going to make the number way bigger than $2.15. Well, let's see. I'm going to make it 1, 2, 3 place values bigger, which means this number wasn't $2.15 to begin with. It's $2,150 all along. Well, I like that a lot better than $2.15. I don't know about you. It can also work the opposite way. Let's take a look at $7.28. Now this is saying that we've got $7.28, but it's actually, they actually want us to take decimal places away from it. We want to go in the opposite direction. We want to make this number smaller. That's what a negative exponent means. So we're going to decrease this number by 4 place values. So let me start with my number once again. $7.28. And I'm going to go in the opposite direction. So I've got to kind of move my dollar sign here. And I got to make sure that we're going to decrease it by 4 place values. That means the 7 is 1 place value. And then I have 3 others that are blanks. And I'm going to fill any blanks ever in with zeros. And the decimal just gets pushed all the way to the end. So this wasn't $7.28 to begin with. It was actually a very small piece or fraction of 1 penny. 0 we can put in front, letting us know that we don't have any dollars, and this is a very small piece of a penny, 0.000728. So you can see the way that 2 different numbers can look. So if you wanted $2.15 times 10 to the third, or $7.28 times 10 to the fourth, well, what would you choose? Yeah, the $7.28 looks bigger, but the good choice comparing the two would be the $2.15 times 10 to the third. Look at what it actually came out to be compared to $7.28 times 10 to the fourth. Just remember, when you do scientific notation, you are unmasking that number and realizing what it actually is in standard form.